Recording progress. Year 6, Lesson 3, Extensive Exercise, Question 3. On the island of Pythagoreia, all vehicle number plates have two letters from the selection A, B, C, and D, followed by a number 1, 2, 3, and 4. A few examples there as well. Note that repeated letters are allowed. Now, this is very important that we can repeat letters. So, how many plates start with double B? So, there is only one combination of letters we could choose that start with double B, which means I have 4 different combinations to choose numbers afterwards. For example, we've got BB1, we could also have BB2, BB3, or BB4. Now, how many plates start with any repeated letter? So, for each combination of letter, we are going to have 4 combinations based on the number that follows. So, this question is really asking, how many different ways could we have a repeated letter? Well, almost asking that. So we have different repeated letters. We could have AA, which is going to give us 4 combinations, whether or not we choose 1, 2, 3, or 4. We could have BB, which we've already decided has 4 combinations. We could have CC, giving us another 4 combinations. And finally, we could have DD, giving us another 4 combinations. So in total, we've got 16 different ways to have a repeated letter as our number plate. For part C, how many plates contain just one vowel and one odd number? So, looking at the letters, we've got A, B, C, or D. The only vowel is the letter A, which means we need to find the number of combinations that use just one A, not 2 A's. So, the first combination we could have is AB. We could have AC, or we could have AD. So for our first letter A, we've got 3 different choices for our second letter. So using the principle of multiplication, we can take our A, where we've only got 1 choice for the first letter. Then we have 3 different choices for the second letter. And then we have 2 choices for the number, because it needs to be an odd number. We could have AB1, or we could have AB3. So that's true for each of those combinations, which is why we're using the principle of multiplication here. Now, we must also consider that A could be our second letter, okay? So that would mean that we've got 3 choices for the first letter, which would be B, C, or D. Then we've got 1 choice for the second letter, which has to be A. And then we've got 2 choices for each of the numbers afterwards. For example, we could have BA1 or we could have BA3. So that gives us 6 combinations in total for each different order. So in total, we have 6 plus 6, which makes 12 different combinations. And I've started to list them out so you can see. We've got AB1 or AB3, AC1 or AC3, AD1 or AD3. So there's the first 6 combinations, and you get the idea for the rest. Now, finally, for part D, there are 64 possible codes in total. Now, that comes from, we've got 4 choices for the first letter A, B, C, or D, 4 choices for the second letter A, B, C, or D, and 4 choices of number 1, 2, 3, or 4. So that gives us 4 times 4 is 16 times 4, which is 64 different combinations. Now, how many have their 2 letters in alphabetical order? And we need to give this as a fraction. So let's think about all of the combinations that have 2 letters in alphabetical order. So we could either have AB. So here I'm starting with all of the combinations that start with A. Could have AC, again, that's in alphabetical order. A comes before C. Could also have AD. So for each of these combinations, I think I could have any of the possible numbers. It doesn't say anything about the numbers. So I could have 4, 1, 2, 3, or 4 for each of those ones. In fact, that's going to be the same for every combination. So we just need to find the number of combinations. Now, I can also consider the numbers that start with B. We could have BC. Not including BB, that's not in alphabetical order. You'd have BD, and that's it. So again, for each one, I've got another 4 choices to make. And finally, we've got numbers that start with C. So we could have CD, giving us another 4. So in total, I've got 1, 2, 3, 4, 5, 6 different combinations, and each of those will have 4 different numbers that follow. So that gives me 24 possible combinations. So as a fraction, 24 out of the 64 of these number plates fit the criteria of being in alphabetical order. And if we simplify by dividing by 8, we get 3/8.